Hello guys, this is going to be another of my lengthy rants. Again on the subject of premature optimization, but it might extend to things about the programming culture. And I realize the more I read about this thing and I think about this, I realize it doesn't matter if A is good or B is bad when the most underlying reason is how the programming culture is shifting, what are the trends, and how some some programmers had an intuition and they threw out a wisdom out there, but most took it as a mantra, as something to be absolute and pedantic about, and the intuitive kind of programming where you're working, you put your mind to think. Should I do A or B? Should in this case do A or B? Is what I'm doing? Is it too early to optimize? Is it too late to optimize? Is it still okay to do it? And that's my decision. That's while I'm writing the code, I'm exploring things and I'm researching things, and I might make mistakes. But no, there must be a mantra that A is bad universally, B is good universally, and I want to explore the culture because I realized this goes outside already, but I realized how far away the quote, the conventional wisdom, premature optimization is the root of all evil. There is this guy Howard who really wrote that. I thought it was Knuth, but I read it was popularized by Knuth. How these things, there was an intuition behind all that. And we know the obvious things about the intuition, like you could be optimizing a very insignificant part and doing micro optimization when the real bulk of the optimization is somewhere else, and it might be we know it's an obvious optimization, but it's taken in such a dogmatic way, and there is so much subjectivity behind what is premature and what is mature. That's why the author here is defining a new term, that there is also mature optimization. There are things that you could do early. By the way, this is the blog of Mick West. It was amusing to me because I'm looking at some UFO junkies, and Mick West is very famous, but Mick West is the debunker of the UFO stuff, and he's doing real extensive debunk where he's using software and maybe even writing his own programs to analyze photos of UFOs. He's into that thing now. He used to be a game developer. Worked in some really well-known franchise. I was surprised. So by looking, I found his blog, and it has different kinds of stuff. Like he was programming for the Sega Saturn. There are a lot of technical stuff here. And I was just scrolling, and then I found on the list here, I ended up finding that one, which I pretty much agree with a lot of what he's saying here. That premature optimization is the root of all evil. He has translated in some kind of mantra that early optimization is evil. And he mentions that the Donald Knuth quote, there is more context into it. He has some nice things here. Most of them are obvious. maybe there are one or two things that I never consider. I think this one, but when is the last time I used the dynamic? So I'm coding mostly, and this one is something I should think more about it. This is something I never. Although recently I was discussing about this with a friend. And this is something I could look at some of my code. I might be missing it and not knowing it. These are more like suggestions, some nice suggestions from a game developer perspective. Although he was coding for the Saturn for the in the PlayStation 2, I think it was his last work. But at the end, I'm not gonna discuss much. It's there is a link in 1970 from Knuth in this article. This is the main thing that blew my mind. He goes, and not because of the code stuff. Some of the code stuff are in an old language called Algol, which is it's a cute language. It has some weirdness, but there is a lot of discussion of the cultural aspect, even at the time. How this whole not only the it's not about the premature optimization. It's about the go-to wars. There was some kind of go-to wars I wasn't aware, and where this other kind of code comes. I know it's coming from Dijkstra. I don't know how it's pronounced. The go-to is considered harmful, but how both those legendary programmers, both Knuth and Dijkstra, they had some intuition in that subject, and there was a whole history of panic and fads. And it was a culture thing. It was a culture change in programming that most people just they stick into these things as a religious dogma in a way. They stick like, oh, now we know this mantra that this is considered bad, this is considered good. You should do this, you should not do that. Always. Maybe that's what humans do, especially programmer. Maybe that's that's the left brain kind of thinking, the left dominating kind of thinking, where you have a set of rules and you know you must always do that, and you don't have a personal intuition around programming. And I have a lot of thoughts about that too. I have a lot of thoughts about how all this relates to programming. There is that, and there is I haven't read that one. I think I've read it in the past. He makes similar points about how this code has been misrepresented. Maybe I read that in the past, but I'm not gonna go here. This is for the future. This is the important stuff. And but I'm reading some stuff and I have some reactions. Mick West humorous says, conventional wisdom. Every year, a fresh crop of young programmers enter the game industry with the wisdom of books and lectures swirling around their heads. One pearl of wisdom is drilled deep into their tender programming muscles. The pearl, sometimes known as horse dictum, premature optimization is the root of all evil. Unfortunately, in the mind of freshly minted programmer entering the game, the code says to turn into early optimization is evil. But I thought of one thing, and it has to do with the culture, it has to do with how we think. Okay, this is a famous quote. This is the most famous quote, the most revered quote. Everybody is praising this quote. Okay. And this is revered as a wisdom. Like, if you are a wise programmer, you know it. And that's the conventional wisdom. But what does wisdom I might just type to make an emphasis. Wisdom, it can mean many things. But one thing is experiencing things, learning by experience, learning by mistakes. That's not the definition, but it relates to that. And you have pearl of wisdom. My God, this is the pearl of wisdom. If you learn that, you will be wise. Optimization is the root. And now, most people take that, transform it into a religious dogma, and they're like, don't you know premature optimization is the root of all evil? You should never do it. You should leave it for later. And they act around it like it's a dogma. They act around it like this thing doesn't exist. The let me experiment, let me junk, let me write premature optimized code to learn, to experiment, to get the wisdom. To develop the intuition of what is premature and what is not. And develop my personal intuition, I would say. Because there is always someone who would say, oh, but what you do there is mature optimization. It's immature optimization. Premature. Oh, there is also immature. You know what I mean? How are these things pearls of programming wisdom when the way they are used stop being pearls of they are programming? No, these are pearls of programming wisdom because someone realized that, not because you made it into a mantra that you have to follow. Maybe you might say, okay, they are pearls of pearls of wisdom that someone else says. Someone did the work for you. But the other problem is it's very subjective sometimes. When is it a mature optimization? When it's a premature optimization? And that depends on your project. That depends on your own intuition, your personal intuition as a programmer, which might differ. And you also have to experiment. You know, when Carmack was writing Doom, I think he used portals for the early Doom engine, and then John Romero made a level, a map. I think it's episode 1, map 2 is that one, with a lot of stairs that make things horribly slow. And I was like, okay, I got the wrong approach. So he went back and tried something different. Figure out maybe BSP trees work better for this thing. And maybe something else work. Maybe if someone looks at Doom code, they might be like, you know, I have a different idea about certain things. And no solution is the best. But there was an exploration. So Carmack could be doing premature optimization in one place, okay, using a different algorithm. But I will write some code somewhere. I'm writing now my code for some kind of DOS demo thing, and I will be trying stuff and realize, oh my god, okay, I thought that would gain speed, and it because you are trying to get performance from here and there, and you have already pushed the algorithm you want to push. Maybe you can go. Maybe you make a mistake. Maybe you can go back, but you are exploring. I wouldn't stop a programmer necessarily. I could point some things out like, okay, maybe this is not the right place, but okay, it's good. I will not make it into a toxic thing like you should not. Oh, premature optimization. This is horrible because everything can be premature optimization. So Mick West says, okay, there is also mature optimization. There are things that you could do early, and you have developed the intuition of certain things that are good to do in. And he's saying some stuff here. And then someone, he says, this is mature, and it's even for this and that reason. So he had to define mature. And some comment says, some comments might say, this thing is, I don't know, memory pools or whatever. This is premature in my view. This is the definition of premature. The thing that you say it's mature is the definition of premature. I think that this article provides good example of premature optimization, of the bad, of the toxic optimization. Do you understand? Even if you say, I'm going with this quote as a dogma, as a religious dogma, I will throw it away. I will throw away this quote because I don't need it. I'll throw it away, and I will still develop the intuition of when it was good to optimize early, to optimize late, to leave some things for later, to go back at all the code and see, maybe I could have done this thing differently. It's not set in stone. Like, oh, that's premature. Everybody knows that's premature. So, Big West is saying, here are some things you should think about, you should consider. And I'll put that in the category of mature optimization. But then it's like, oh, that's premature. Also, it depends on what you're doing. Maybe some of that stuff, in a case, are premature. In a case, in some case, it's mature. But maybe you don't care at that point in the project for something because you're in a hurry, or because you know that thing is gonna run. I don't know, some menu code in your game is not gonna run too many times. And to me, it's also up to you. If there is an, I'm becoming radical here. I'm like, I disregard. I'm telling to all programmers, especially young programmers, do mature optimization, do premature. You think you're doing premature? Try it. Get the intuition. Write something that will bite you in the ass so that you learn. I'm and people will come and tell you, oh, this is bad, this is premature. The problem is we have created an absolute. We have not. Normally we should say, okay, premature is caution. But no. We said premature is toxic, evil substance. Dangerous. I think that's bullshit. Because you close the programmer's mind. You tell them, you intimidated the programmer, especially the young programmer, and the young programmer thinks, oh my god, if I touch optimization, if I care about performance, or if I do a performance test, maybe I want to experiment with performance, I might touch on the premature, and this is horrible, it's gonna look horrible, I'm gonna get the dirt, This is what I'm trying to convey. I think we should get away with all these outdated quotes because, and you even see in the old article from Kunu, I mean, this is 50 years from now. We are obsessing about things someone said 50 years from now. I think Knuth had the intuition, and he shows that. And he shows that even then, that culture I'm complaining about, it was the same thing in programmers' mind. Most people take these things as dogma, and they just stopped thinking. They stopped allowing others to think, to freely think and see what works and what doesn't. That's the interesting. It's what Nick West says. It's amusing the amount of people who quote Knuth on premature optimization, who are also firm believers in go to consider farmer, not realizing the paper they are quoting, which is from here, is basically a paean to both go to and mature optimization. Paean, 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 paean. A song of praise or triumph. Ah, it's Greek. Yeah. I've read parts of it and I realized it's not a paean, but it's a both pro and against. It's having a lot of examples where, look, they told me here to avoid goto, and it made the code worse. And here it made the code less performing. While in that other case, someone said that by replacing goto with something else, they made the code more clear and easy to understand or something. So he's over the plane to correctly show you that you cannot live with absolute. And I'm going, because I'm going to try to find some. This is log. I'm not gonna read. I have been reading somewhere, but then it starts with examples. I have been looking at some examples and maybe skipping and finding some good stuff and the conclusion. Because it's even a 70th thing in an old language. And I will show you how there was a reason that people freak out with GoTo, for example. No, I'm chasing on two subjects: GoTo and Premature. Premature is mentioned in this article. That code is mentioned here. It might be from here, but it's from the other guy, Howard. But they all relate. It's not about either of them. It's about a common relation with a programming culture of taking things and making them dogma, and stop with the intuitive creative programming where you learn as you go and you make up your own mind and you don't stick too much into dogmas and you don't form religions around. It's very interesting because it even says about things that happened at the time, and there was a panic, and professors got threatening levels for being pro GoTo or against GoTo. Like, what the hell? It's like when you hear something about someone got some politician got a threatening letter from one group of people or other. Like, but that's not for serious. That's for GoTo. And now you realize how stupid it is. I don't care anymore about GoTo. If you use it, I'll read your code and say, okay, he's using it for that. Fine, okay, it's easy. It's not some complicated spaghetti thing. It's I'm fine with it, and I have a general intuition now about reading other people's code. Like how you have to be open. You might see something that seems horrible. Okay, sometimes there are things. Sometimes there are things that could be written better. I see my own old code, and I'm like, oh, what have I done here? But instead of overreacting and basing correcting the code based on your mantras, on your absolute mantras, you have to have an intuition that okay, that's not the best, that's not how I would write, but okay, I kind of get what he's doing. Uh, if I write it, I might write it in my own way. I have my own programming style. We both, me and the other programmers, they have their own programming styles, which they evolve. That's the important. You evolve. You look at your old code and you write every time you write things different. So there is no point to have absolute mantras that something is good and so you should use it and something is bad. You can mention things to make a point, man. Maybe we should say, I don't think this one is good for that reason. But that's my opinion, that's my preference, and I'll explain myself. But we should not make them into absolutes. Okay, I'm repeating myself. I might skip some text. I might find the text that I found interesting. The thing is, this thing it doesn't tell you necessarily you should use Godo or not Godo. It focuses on two issues. It focuses in if we can write things without goes to statements and keep the efficiency and improve the syntax. And it's either for iteration of or error exit when some people like to, and that's fine. I think the Linux kernel had a lot of gotos, and some were related to check early if a condition is wrong for some initialization routine and jump to the end with where you print an error and return. And or you want to return early from somewhere. Yeah, because I had these discussions. I said I'm not defending Goto. The code I have written from the last 10, 20 years, you will find zero Gotos because I didn't need it. And someone told me, how did you not need it? What about error exit conditions? Where you're initializing a bunch of things on your main. So some people's programming style, they're doing like that. I might have some other function in it that I call from where I am, and that will return early and print an error message. But again, I don't care. I don't consider one or the other the right way. So this is exploring that, and then a methodology of program design beginning with readable and correct, but possibly inefficient programs that are systematically transformed into efficient and correct, but possibly less readable code. So there was a trend where people would take code that had go to statement or didn't have go, and they would try to transform from one to the other because it's better or it's worse. Instead of writing the programs on their own from scratch and trying to design it, and if a go to helps, fine. If not, okay, I think I should go faster with that. And see, that's the thing. That article is not making a final statement necessary. It's just more approaches at the time. Yeah, okay. It's more about the most important is the structured program. It's not. That's what he might be saying. It's not like, oh my god, go to. You use the go to, so it must be bad code. Because you can try. In some of the examples, people were trying to remove the gotos, effectively making the code worse. They were jumping over hoops and adding more stuff. They make things harder to read and less performant in some cases. So he's mentioning the history is he's mentioning Dick Stein 1972. Is that the place? I'm gonna catch the good part because I read it yesterday. And It is impossible to read the reason without having to change your. Nah. I have a. It was that from. These were before my time. I think they might be classics. This is important. Each of us naturally is developing strong feeling one way or the other. The way we write programming, like that's the right way of coding. That's the right way. As we agree or disagree with revolutionary leaders, and when people quote, I'm not against Knuth or Dijkstra. They're fine and they have good intuition here. Actually, they try to correct the masses. Like, hey, we are telling you this to. We're just describing it. We're not telling you to believe. You will see that both of them, they are telling, don't make this into a dogma. Programming is about this intuition. It's not about following rules. When you are structuring your program, you are making decisions. You're not following hard written rules about the right way to do it. And and Mick West jokes about that. Like a revolutionary leader in programming, he has written that, and everybody takes no. Are you better than Knuth? This is disrespectful to Knuth. uh, he said that nobody wants to argue with Knuth. It is the equivalent of arguing against the second law of the thermodynamics. And then he goes. The problem is that people misunderstand what. That's the problem. A very important person says something, and everyone takes as a mantra, twist it, and now it becomes religion. But the original person, by reading this, I see that Knuth has a great intuition, even in the social cultural thing that was happening at the time, and it still happens in different ways. And even Dijkstra had the intuition to say, don't make this into a mantra. That's not what I was meaning. So this is the important thing. We're getting hot about subjects, we're following the leaders of programming, and then we say we stop thinking for ourselves. We make it into that guy said that, and it's a rule. It's a rule of programming. Now I have to go faster with that. So. Yeah, he's very apologetic. Like I have been working with structural programming, and these are just my opinions. I just want to point some stuff. The abolition of Go too. There are doubtless some readers who are convinced that abolition of Go to STEM is merely a fad. And they may see the title and think, Knuth is rehabilitating the Go to STEM, we can go back to our old ways. Finally. But there is another class of readers who will see the like, when are diehards like not going to get with it? Like, so everybody's reacting in the extremes. Okay, it's about the my both sides balance viewpoint of the proper role of GoTo. And what I have seen is he argues that was the 70s. Language was different. This algol language, I don't. It might not have additional statements to alleviate it. He kind of went this now. Half of the people think, see, he said he is for more pro good. It doesn't matter. And look what Dijkstra said. Dijkstra the originator of this go to consider function, he recently wrote the following. Dijkstra never said, just go fanatic with this. Please don't fall into the trap of believing that I'm terribly dogmatical about the go-to stem. I have the uncomfortable feeling that others are making a religion out of it, as if the conceptual problems of programming could be solved by a single trick. Man, this is so important. And that he said that by a simple form of coding discipline. That's the culture now. Not just go-to, not just premature optimization, but all kinds of things. You should not use this, you should not use that. It could have been suggestion like, here is my experience with this, here is my experience with that. Do what you will, but I'll tell you what I found out about certain language constructs and certain attempts to optimize it. And the reality is fluid. The reality is nothing of this dogmas. And I don't think young people should learn like that. They should learn like shove something into their brains till they become automatons that never do this or that. Because they never develop the intuition. They never develop the intuition around programming. But he said, this is the phenomenon. This is the whole thing. It's irrelevant with the go-to, with what kind of modern things people are fighting over. It's like we expect that the right way to code is this, and if you just do this, everything will be fine. And that started with go-to, which is silly by modern standard because it's such an anachronistic thing, such an ancient keyword. It still exists, but it's not the problem anymore. But that it's like something that never went away, It's otherwise it seems that the fanatic advocates of the new programming are going overboard in their strict enforcement of morality and purity in program. Sooner or later, people are going to find that their beautifully structured programs are running at only half the speed or worse, half the speed of the dirty old program they used to write, and they will mistakenly blame the structure instead of recognizing what is probably the real culprit. And he says specifically the system overhead caused by typical compile implementation of Boolean variable and procedure calls. Some of them might be anachronistic. I don't know if. I recently found out that Casey Muratori doesn't like the bool type. He had an explanation. Okay, those are examples related to the architecture of the 70s, and some of them might be still. Like, sure, if you call many procedure calls and they can be inlined. So, yeah, that's not important. The important is the culture thing. People are gonna fly. It's like the object-oriented programming fad. Like, oh my god, it's the new thing, everything is fine, and then and then some people started realizing IQ bell curve. Like that, but a different one. Damn it. I can't find it today. So there was this meme where this guy goes like, I'm writing things in pure C. This guy with high IQ, I'm writing things in pure C, and the guy in between is like, no, inheritance, base classes, virtual function, templates, whatever C++ things. It's like, I can't find the correct one. It's like you could go with the new stuff. Oh my god, this is the and you realize, okay, I'm making my programs worse. So you will take this trip. This is why it's important to premature optimize, so that you learn by your mistakes. If there were some horrible things, you have to go, you have to reach that. You have to go through some of the funds. If you want, if you want to waste your time or not, because there are so many fans, but you have to not allow people to tell you you should not do, you should never do that. This is forbidden. Why? You have to try it and figure out, and then realize, okay, I guess the other way of doing things goes better. Sometimes you might find good stuff. Maybe not everything from the new way of programming is bad. But that's that. There will be like, what were we doing wrong? We might have another revolution on that, but probably not, because people realizing that some of the modern programming paradigms are making things are not helping, they are making things worse. Although it seems to be going the other way, because very few people go to the other side of the curve. Anyway, I'm being very slow here, so he's making a reference to some old historical thing I didn't even know with the new mathematics. So Bertrand Russell published some paradox. I haven't fully understand what was the fuzz. His famous paradox about the sets of all sets which aren't members of themselves. I'm supposed to be a mathematician, but no, I can't understand what that means. But I was trying to think of such sets, and I don't understand that. I need to read about that. So what was the paradox? Yeah. But the thing is, it started some kind of division where some people went with some intuition in this law. I don't understand it, but it seems like the go-to thing. So there are like two competing school of thoughts, let's say, and they were being like, you should not use this because this is not pure mathematics, or this is not. You should use that. They would excluding things. That's not the real mathematics. That's the real mathematics, and it says that was historical, and this is what happens in computer science. Now he said in the late 1960s we witnessed a software. I don't know history. What is this 1960s crisis? Which many people thought was paradoxical because programming was supposed to be so easy. I don't know. As a result of the crisis, people are now beginning to renounce every feature of programming that can be considered guilty by virtue of association with difficulty. Oh, that's too hard. It must be bad. I don't understand this. So, it reminds me of more like if it's not it's not clear and easy to read. You know, if I read code that you wrote and you think I have written the most clear and easy to read code, I might not understand it. It might have some high level abstraction that I don't understand, or some new features of a lot of the modern language that are not, they are not the for loops and the do whiles and the if statements that I'm used to. There are some modern stuff that, like, okay, you pack things together in some new things that effectively do what I do the old way, but it's easy to use. For me, it's with a direct look, I don't know what that does. So what you think is clear and readable and easy to understand might be harder for me because I'm not familiarized. It's the opposite. If you look at some old C code, you might think, oh my god, this is impossible. This is so low level. For me, it's like you're speaking my own language. So this whole thing, some people they both think, okay, at least he thinks Knut thinks they renounce every feature of programming that it must be guilty because I don't understand it. Not only go to statement being questioned, we also hear complaints about floating point calculation. Nowadays, the opposite. It's like floating points is fast. You must use them. And I guess, yeah, they are easier. Fixed point, they are a bit harder to mess around. Global variables, yeah, that's a very common thing. Semaphore, I've heard that. I should know that. Does it have something to do with threads or something? I don't know. Pointer variables, of course, and even assignment statements. Uh, so anyway, you see, people become polemic for, oh my God, this and that thing is bad. Soon we might be restricted to only a dozen or so programs that are sufficiently simple to be allowable. Then we will be almost certain that these programs cannot lead us into any trouble, but of course we won't be able to solve many problems. Are we trying to be clean? Are we trying to be... I think there is this new thing called functional programming, for example, which I think the goal is there. It should be stateless, no memory state. You don't have some variables. You have a function that takes an input and returns an output. And I haven't tried it. I'm like, okay, why is there so much effort? Because someone decided it's bad because if you have variables and you change the state of a variable, you might have changed the variable that is read by somewhere else, and then something else goes wrong somewhere else, and so we must have we must do everything extremely clean. That's the thing. But then when we are trying to do, it's like political correctness, man. I don't want to go there. It's like that thing is problematic, that thing is problematic. Now we find something new is problem where we're not satisfied. The thing is, I could read the most clean code and still think I still cannot understand it, so there must be something wrong. So we must remove another feature. We must make a programming language that is an empty white sheet of paper, you know. And it is the same now. We'll go to it's the same as games. Like we made this game, but a gamer was confused by that. So we must not confuse the player. So we sanitize and sanitize and sanitize because we are obsessed with this culture of over clearness, and it reflects all places. It reflects the mania with political correctness. It reflects the how easy the games have become, and how they remove features that would be fun for me, but it might confuse players. We simplify everything, but it's fine. But this has gone the other way. This has gone. We react like we see something. What is this code? Like everything is toxic, and everything must be sanitized. Everything must clean, and then we are unable to do the real work. I think this is the wrong. I think you should not in a program. You should not. The goal, at least, you can use it if you want. You can say, okay, I like to get away from the machine. I like more abstraction, but you shouldn't make it like the absolute goal of the programming culture. Like everyone should do that. The culture goes one way. It's pushing everything there. Why? Because of that. Okay, maybe it's not a reality because low-level programming exists in certain sections in game development and operating systems and whatever. So I might be complaining with a trend, but just and I'm fine if someone wants to get away from the machine as possible, but it has become such a mantra and such a extreme reaction to the ugly Anglian code thing. Like, oh my god, this is horrible, this is toxic code, this is ugly. We have to abolish it. No, you will not abolish anything. You can abolish it from your own programming style if you want, but you're not gonna abolish it as a general thing. You are just a different school of thought. And this is what was happening. Even then, it says that in the mathematical side, those intuitions teach the others something, but the other school of thought also did something good, and it says won the battle. So maybe there was a fuse, and he believes that there will be this will happen in the computer. Like, okay, maybe we can abolish GoTo, but we might improve our languages. Purists will point the way to clear construction, and others will find ways to purify the use of floating point arithmetic pointer value based assign so that these classical tools can be used with comparatively safety. Okay. Yeah. And that was in the 70s, and he was thinking programming will change. Did it? Somewhat. But the code in this one, were still very C-like. But that's fine to me. We should not obsess. Like, there is a new thing and we have to throw the old thing away. Again, someone can throw but you shouldn't be forcing like the right way of programming, the future of programming, and you are living in the past. Because we end up with junk. We end up with junk. Programming could be a creative, intuitive ability. And anyway, I'm lost here. I'm sorry this is going. I'm going to be finishing soon because I think I there are only 10 years left. What? So they are both pro GoTo, both pro and con on GoTo with various examples. So it shows that you can be dogmatic with that stuff. If you hate it, you can. But this shouldn't be mantras. Even GoTo. GoTo is an old. It is a mantra. There is a good reason now it's a mantra because if I say I use GoTo, it's like I'm saying I'm a toy programmer. I'm not a professional programmer because GoTo is also associated with basic. And I know the real argument is but the flow of programming. We will talk about that. But it's also it's a keyword that immediately so if someone comes and says I'm a professional programmer, GoTo. Oh my god, everybody's gonna laugh. Professional programmer GoTo. It's like you're saying I'm a professional nuclear physicist. The Earth is flat. It sounds the same. Because it's, but one because of this old culture, it started from there. So if it started from culture, maybe it's not real. Maybe GoTo a professional programmer can use. Man, the Linux kernel. Last time I heard the Linux kernel is riddled with GoTos, and there was someone trying to remove them. There was someone who wrote some paper or something where he tried to remove all the GoTo statement for why? Because of the culture in the 70s that told you this is the devil. There wasn't an attempt to understand that GoTo there is for that reason. That's fine. Why? So software is unreadable for 1,000 more reasons than go to. Anyway, I have to continue. I like this one. This is just a dog. There was a Japanese computer scientist, Dr. H.E. Goto. At this conference, blah blah, I had the pleasure of meeting Dr. H.E. Goto of Japan, who cheerfully complained that he was always being eliminated. I like that. So he says about the history. The first programmer who, but look, systematically began to avoid all labels and go-to statements. It's like a goal, like was this or guy. And he has a method with the flow of control. He had some method to how he would gradually remove the go-to statements and replace them. This becomes like, and I'm thinking we are talking about mature optimization, premature optimize. Oh my god, it's premature. Things like that could be premature, not optimal, but premature. Here is your code. Oh, I must remove all go-tos prematurely, like because it's bad. It's like I have a list of things to do all the time. First, we remove the go-to. Then we replace this thing with that because it's faster. Isn't the premature thing when some guy comes? I'll tell you a story. Uh, I always used to write. And someone once came and told me, and to be honest, it became a habit, but it's and I didn't believe it exactly, but he told me, you should not write I++, you should write plus plus I because it's better for the compiler. That's an optimization gimmick. That could be the premature guy who's, you might have written some really complex, cleverly optimized algorithm, and that guy comes, ignores all that, and says, "Oh, I plus plus can be a plus plus I. Oh, look, job is done, optimized." This is like, this is a gimmick to me. And he later told me, yeah, in reality, whether you write plus plus I or I plus plus, it doesn't matter. It doesn't matter. But it's good to do it because plus 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 is like you did is he in assembly or something. Why I plus plus could in the past could be like move. Maybe I'll write it. Okay, I can write x86, but I can easier write things in z80 because I cannot think. It's like you increase that, but this one would be like. Also, you have to load it. Or it could be on a register. This could be like. It doesn't matter. It's a stupid example now. LDA commands ink A, LDA is. I mean that also could be like it could be LDA command L. No, not engage L, ink A, and then you use it. You use this value and then you use it. But this might be like, oh, some compiler could say, I read it from memory, I increase it, and I have to write it. Actually, you don't write it, but it's bullshit. There was something like that. Also, the other thing is, what if I is a class object? Maybe the plus plus operator will be called read the object from the pointer, call it instead of some kind of bullshit like that. It might make sense, but my opinion, this would be like, here is something extra to consider. But it was presented to me like, oh, you should do that like that. I'm so clever now. When you, but you, and it's the same. And I know someone will say, oh, Mo, but that makes it. Yeah, I told you, yeah, it might be different in assembly. Maybe not anymore in modern compilers. Maybe if I wasn't an integer but a class object, and the operators is how you define the operators. Okay, it's you who, unless you use some kind of STD library thing that takes this operator, you didn't realize that things happen from behind. But this is gimmick. Now the other thing is, and nowadays I write it like this, but not because I believe in this game, because I somehow connected it with the ink AGL thing, or ink A, whatever. In my mind, it's like, but it's pointless. I'm like, why? And I will go on the premature optimization thing. These are gimmicks. The guy who was like, go to, haha, will be like, oh, you should replace this go to with that. Oh, you should be. He's working in a mechanical way, in a set of rules. Make remove go tos. Always use A. Never use B. This is gimmick optimizer. I mean, it's good to know, but sometimes you might be missing the whole picture. You might go with that. You might have a damn slow algorithm and go, oh, I optimize it. Yeah! And that I guess that reminds me of, we will find it soon, of actually, because it's gonna be very, that could be the reason. The conventional wisdom shared by many of today's software engineers calls for ignoring efficiency in the small. But I believe this is one thing that could happen. This is simply an overreaction to the abuses they see being practiced by penny-wise and pound-foolish programmers who can't debug or maintain their quotes optimized programs. Now, it can be relative what is an optimizer, but my thought is that maybe at the times there were many people that were, there were many people that were memorizing that stuff, whatever. Memorize. And they would come at your door. Oh, you should change this with that. Oh, you should do that with that. And you had the really good algorithm, and they would be pedantic by that. And maybe this is what make many people get pissed and be like, you know what? Fuck you. Premature optimization is the root of all evil. Okay. Because that premature could be the penny wise and foolish guy who came and said, oh, you know this and that. I'm trying to understand why. But then people lock their brains. And you know what? If my programming style is to obsess about I++ and ++I, that's fine. I see it fine. I'm not gonna see in ++I, oh, why did you do it? That doesn't matter anymore. Do it in I++. No, maybe someone likes that. Maybe someone likes how it looks. I like how it looks better nowadays. So that guy told me that because you know that justification. These are set of rules, but they have justification. So that the guy will say, I'm not just saying that as a religious mantra. I'm saying it because in assembly this is what happens. Yeah, but you're just nitpicking things that I don't think it's so important. Maybe this should be like nice things to consider, but don't obsess about it. Even all the things that Mick West is saying, I mean the technical things, not the sociological, like avoid allocation, avoid this. Maybe this is avoid. When you say it, it becomes like, oh, don't do that, it's bad, and you lock your brain. You are like, the expert told me I shouldn't. Maybe this should be nice things to consider, something that you didn't consider, something that might be eating your performance. I'm allergic to this rule because they start with good intention. They start from someone's. Mick West has the experience in game development in his own project. It's like these are the things that have beaten our asses when we were developing things. Someone else might have a different list where some of these things are in the list and some other. And everyone has these personal stories where they form their rules, but they should not be the rules, the absolute rules. They should. But then again, it's nice that we have some ideas about this and something to consider. But we should not. I mean, you get it. This video could be 10 minutes. You get it. And here is a thing to consider. And I bet this is the premature. This is the thing that broke the camel's neck. I might be using the wrong allegory. That's the thing that people, premature optimization, those silly gimmicky programmers who micro optimize stupid things and they are messing up without project while and here I assume that I wrote a really complex level optimization. Who am I? And maybe some of these things, when you have finished your run, maybe some of the things can give the extra boost. And you could try it, but don't make these things. Another thing that I hear is common is, I don't know, yeah, let's put something like. Another thing is, I used to hear, replace for loops. Now, I always liked the for loops because it was very obvious that this loops from 0 to 255 to less than. If I put an equals, it loops to 256. It would be easy to see range. And at best, now, and for some reason, I would not do while something count this on me then, or count this on 256. I still have. I'm writing do whiles, but that could be wrong, for example, because it goes from 256 to. That's wrong. It never reaches 0. It could be, I guess. That could still be wrong. Okay, 255. If you use count inside. Or you can see while Baba plasma count something. But see, I'm already. I can write this blindly. I can write this almost blindly because I'm sure I will do something like that, and I will end up prematurely escape the condition, or maybe maybe I do that and I forget that. So there are so many different. So this is always easier to read and know that you go exactly from 0 to exactly 256. I have made mistakes many times for it. And that's why in my old code, I was doing, yeah, one of my most famous demos was that one. And I was pushing the machine, but I wasn't really pushing. It was C code. It was an ARM at 100 MHz. Much better things can be done. And I was learning. And I see the code now, and I have done many stupid things, but that's irrelevant. But I wasn't doing optimization like this. This didn't. I wasn't even using. Yeah, there way I can see the code and improve, and I wasn't even doing that. And I don't know what I'm going to see. Much later, in also old school project in the DOS demo we're doing. Sometimes I try. Maybe I have a single loop. Maybe I have a triple or double for loop for my pick, and I try. What if I replace this with a while? And sometimes while tends to be same speed or even slower than for. And I'm like, what? I always heard that while is better because this would be like in assembly, LD, 250 decay jump not zero ladder. While this one would be like LDA, 0 or XOR A, but okay, it's premature optimization. Ing A, compare A, comma. That wouldn't work, by the way, because it's 256. It had to be. So you will do the extra compare, and that could be similar with other languages. So. And I was told, oh, you should make your for loops to do while. And someone made some for loops to do while, and he was like, oh, in the proof, now I will make it a rule. I will make it into a rule. But it's not always the case. It's not always the case. Because I tried cases, and sometimes same speed, but sometimes tiny faster. It doesn't matter. And at the end, I did this demo, I did other demos, I tried to optimize all kinds of anything I could understand, and I never replaced at the time any for loop with a do while. I think at least. I might see and find one. I always wrote it and wrote things in the form that and maybe in some case I'll gain 1 or 2 frames. Maybe I get 5 frames per second. Maybe I'll get a good improvement just for that. It's something. All of these things are nice things to consider. It's not absolute. It's not that you have to, oh, let's go through all the for loop, and sometimes I write a do while loop. Okay. I have some intuition, maybe it's better, but I might be mistaken. Because man, it's all over the place. Depends on compiler, architecture, specific code you write, who knows what else. You cannot rely with mantras. You cannot rely with mantras without testing. All of that stuff should be nice things to consider. And I made a big run here. Because some of these people were making it like a mantra. Let's go and replace every goto, and then they. So that guy has the. Yeah, so that was quite okay. Can you write this algorithm without using all this? So it's a dogma. there was a bit of a fun. Like, oh, you should go get away. Everybody's doing that now, and people are. Do you know the why am I writing? So the fizz buzz. Uh, Programmers like to mentally masturbate. I realize I like to mentally masturbate. I like to micro optimize or mega optimize some code to run on the lowest hardware possible. It's a bit of instead of finishing the thing and make it work. I like to. Sometimes it's micro optimized, sometimes it's mega optimized. It really counts. And it's like, okay, it was worth that I wrote that piece of crap because now it's running like absolutely fucking best. When someone posted the fizz buzz, there were a lot of replies. Look how I made the fizz buzz. Everybody was mentally masturbating of his fizz buzz alternative. So everybody is reacting like, oh I will flex. Code flexing. Is it like muscle flexing? It's like look at my muscles. It's like look at my coding muscles. This is what coders like to do. Another way to it's not bad. We have to understand our own nature, man. That thing, GoTo became a fad. It's like, look, I have a technique to replace all GoTo. Look, I'm flexing. Look, I took your GoTo code and make it into something completely different, which I think is more clever. But sometimes it might be jumping over hoops, you know. Because really, it might be. You might have some triple thing. Maybe you do some voxel algorithm. Okay, you get it. I'm going too slow with that, but you know, I enjoy it. If condition... Now you could say if condition go to label. But you could say if condition break. And... oh, but break is gonna go here. It's not gonna break. So someone would be... I must not use go-to. Boolean F. F is true. If F break. If F break. Someone would do that because I must show that I can write things without the use of goto. So I must make things, I must write 3 lines of break or something. You know, do you understand it? We are mentally masturbating because someone on the 70s said go-tos are considered harmful, and we took it as a dogma. We didn't took it as a discussion, as an intuition. And we were like, look, I am so clever. I didn't use go. I'm the professional programmer. I'm not the dirty programmer. And I wrote this monstrosity. Now, if I didn't want to use goto, I would use a return. So there are other ways. Make this into a function. Yeah, void something. And maybe you want to return a bool or a value. Else return false if it didn't find an element in this volume data or something. Suppose, you know. I could do that, and now look, I have a return, which is effectively a goto at the end of the... And technically assembly, it's very similar, and you have jumps and stuff. So there are ways to write. Maybe you don't want to make it a function. Maybe you have... my mega function, and you want to run it here. Maybe you make it into a, what the fuck is the lambda function syntax? I always have to look this up. Something, whatever. Okay, because some people might say, no, I don't want to make this into a function. I want to return here. I want to put a go to, fuck you. Okay, maybe you can do that. But maybe you want to use a go to. I don't care. I will accept your go to. Because it doesn't matter. It's different ways of doing the same thing. If it's not a horrific spaghetti code where we go to up, down, left, right, up, down, left, right, over the place, who cares? If that's your style, if you write the spaghetti code, then I won't care anymore. Because the problem is not that. The problem is that. The problem is the culture. The problem is we are not learning to think around programming. That guy is flexing. I'm flexing sometimes when I show you some crazy optimized that who cares. It has its use. It's like a puzzle. It's like a math puzzle sometimes. Look, I can rewrite in a different way. But is it? Do you also prove that, oh, I replaced the go-to, I'm so clever, when you are making something that might not be convenient for someone? Do it for your puzzle, but don't make it into a dogma. Again, it's that thing. We flexed, we became pride, and we not just this guy. There is examples of many people who follow that. If you look carefully, you will find that surprisingly often a go-to statement which looks back really is a concealed for statement. And you will be pleased to find how the clarity of the algorithm improves when you set the for clause where it belongs. If the purpose of programming is to teach algorithm, the user blah blah blah. There is something important. Two programming department managers from different countries and different backgrounds. The one mainly scientific, the other mainly commercial, have communicated to me independent for their observation that the quality of their programmers was inversely proportional to the density of go-to statements in their programs. And that says the less they try, the more go-to they write, or the less they try, the more they try to possibly avoid go-to, the more the quality dropped. They were spending time to make the code clearer by avoiding the go-to statement. So in one case, okay, that's not the important, but that's one view that we have seen that the more go-to, the better. The less go-to, which is not the case. It might be that they try to jump over hoops just to prove that, look, I'm so clever. I have done various programming experiments in modified versions of Algol 60 in which the go-to statement was abolished. The later versions, where there is no go-to, were more difficult to make. Now this is the problem. We are also so familiar with the jump order that it requires some effort to forget it. In all cases tried, however, the program without the go-to statement turned out to be shorter and more lucid. Okay, here is the opposing view, that in my case, it was harder, but it makes the code better. And here they say they write worse code. So, this is I realized something. It might be mentioned lower. We are so familiar with the jump order. A go to statement that looks back. I think it's mentioned later, but I will prematurely. You know, the more standard thing you learn in assembly is that you have a label. You say, okay, load 8.64 decrease 0 not 0 comma label. And when I have to, or it could be LDA comma 0. I know this is XOR A comma A, exclusive array with itself. The alternative is okay, increase A, compare A to 64, jump not 0 comma label 2. So this is equivalent to less than 64 and not less or equal. This is equivalent to that. This might be equivalent to something similar, or a while statement where you start the count from 64. Yeah, that's equivalent to. Yeah, I think you get it. While something. Am I writing? Is it do? You know, I forget about. This is pseudocode. Okay, yeah. Count this 64. This is equivalent to that. I think that should be do while. Do you see that I'm more intimately familiar with 4 because it's a range thing. But in both cases, usually in assembly, it's easier to write as at the end of your loop, decrease the value and jump upwards. So yeah, so this would be equivalent to. Yeah, I guess you get it. So I think this pattern was very common, and people will do things like label inde equals 64, a minus if a go to label. People will do that. And it's even a go to upwards, which is, I guess, worse for the flow than if it goes downwards. But here's the point. Now I realize historically why people were freaking out. Because we might see it later. Most of the students would come from the assembly school of thought, and then they would have to learn a new language, and they would instinctively go to that. They will skip that. Which, for me, this is more intuitive now. This is more easy. It's from 0 to 60 to 63. And that looks from 64 to 1, but it does equivalent the same thing. You could say 63 and yeah, something like that, or yeah, whatever. That might be wrong. That's fine. See, the most intuitive is always no. To me, it's intuitive. If you taught me today, you can use GoTo as much time as you want. You can go haywire with GoTo. Use liberally GoTo. If you were like, and someone say that teacher is horrible. He's destroying your mind. I would still use that. I would still prefer that. Because intuitive is since the time I learned basic, and I learned, I had the trouble to convert this one easily into assembly without some extra thought. And I would have trouble to think, okay, I want to look from 0 to 64 or 0 to 64 inclusive, for example. It would take a bit more thought to write. Those are very simple, but I tell you, it would take tiny minutes. So I would always go for that. I will not do the bad cases of go-to. So that's pointless. But at the time, and maybe this algol, it had for loops. Maybe it was awkward, and some statements were awkward, and people preferred to translate their go-to, the things that they learn. Everybody was learning assembly then. So they do the same flexing games. Oh, they see this. Oh, it's a mathematical puzzle now. Like, oh, can I remove this go-to thing? That was happening at the time. Even those people who write the articles, they were like, I had a trouble to go from the jump thing because I was thinking the way I was writing assembly to the for loop. Personally, I had the opposite trouble to convert a for or while loop. Although it's very easy, but I'm telling you that to go today and say, "Oh my God, go to this horrible," people are gonna start writing spaghetti code. They won't, because we have the right language. They will prefer to use for loops. We can get away with this alarmism and this kind of you should not do this, you should not do that, and learn them, learn them, because I realize there was an issue then, but we escaped it. We didn't need to. People started using the other forms. So even this professor had a problem. He found the for loop more difficult, which I find it definitely much easier. And they were writing the jumps like that, like it was assembly. They might be porting code. So So there were some people in the 70s that were obsessing about a single keyboard. That is, it's so ridiculous now. And it made sense maybe back then. And everybody said, oh, should be abolished, abolished, abolished. Like we're killing someone's mama or something. If we, there was this alarming, there was this the strong statements. So there was some history there. But again, you might be missing the point. It's like that became a fad. That became a. It's a history I didn't know. I thought that was something someone said that's it, but I understand why it's so strong now. Why it's so engraved in people's mind. Why people are still obsessing about that. That. And see, in fact, the discussion has apparently caused some people to feel threatened. Dijkstra once told me that he actually received a torrent of abusive letters after publication of his article. Do you remember that article that I wrote that I said something and then I got death threats from this kind of people or that kind of people for the serious political stuff, but this is for go to, man. I mean, the majority of programmers I don't know, they become religions. You should always think these are nice things to consider, and you should use your intuition. And everything is fluid. You can tell me something and might not. And we are flexing, and that's fine. I do that too. I do that on crazy optimization for retro platforms instead of finishing up things. We have to understand our needs. We don't have to, oh, we are flexing, that's bad, but know that you're mentally masturbating. You are flexing, code flexing. And see, Knuth was affected. The tide of opinion first hit me personally in 1969 when I was teaching an introduction programming course for the. I remember feeling frustrated on several occasions at not seeing how to write program in this new style. I was forced to. I should not use GoTo, but here a GoTo would be helpful. But I have to jump over hoops to do it. I would run to. But everybody says that now. I would run to Bob Floyd's office asking for here, and he usually showed me what to do. This was the genesis of our article. We presented two types of program which did not submit gracefully to the new prohibition. Right? There are things that made our lives harder if we follow it like this. There was no way to implement certain simple construction with while and conditional statement substitution go to unless extra computation was specified. It's always this abolish the goes to statement. It's our new enemy now. We are defining ourselves by the single keyword. Yeah, and it says that there are some things I don't know what this label with. Now this might be parts of some of these languages. It's always algol here. It says that's a phenomenon I have seen too. This is important. There's always this flag. Oh my god, we have to avoid go-tos, and you might use something that is basically go-to, and you have to call it, that's not go-to, it's something else, but it's basically go-to. It's like if you use switch cases and other stuff, and it's always, yeah, but switch cases, the flow is easy to follow and blah blah. By the way, people are afraid that, oh, if we throw a go-to there, the universe is gonna collapse. Why? But do you know there is something about the programming flow? It destroys the programming flow, blah blah blah. Okay, haven't we destroyed the programming flow with all the modern C++ abstractions, classes, and inheritance and other stuff, and other modern stuff we're doing? I was looking at signals. We use in something in my job we use signal, and my god, this is a go-to squared. We use boost signals, and it might always be like, yeah, there are good ways to use signal, but you must be doing a bad goal. Okay, then there are good ways to use go-to that don't destroy the flow, and it's much easier to follow. Go-to, people think go-to is a thing, but it's like modern programming. It's like you are in a nuclear wasteland, and you threw a garbage you threw a little garbage thing. And you're like, what are you doing this guy? But we have a toxic waste here. Why is everyone? If that ever comes, it's bad because flow. Yeah, the flow is destroyed. We are accepting a lot of modern programming paradigm that makes things 10 times as toxic as your go to. I don't understand it. And then this the example style. It's a weird language. I think they talk a lot about alcohol, so it is this alcohol thing. Yeah, it can be read like C. I was looking that if this condition then go to found fee. At first I thought there's a found. Where is the fee? And I think now fee is that was the language. They reversed the letters to close a bracket or something. Like okay, this stops here. It doesn't go below. Now, obviously, I'm not gonna explain the examples. It even says I don't really like the looks of fee. And he says students would make fun at the time, giving a paper containing the fragment ESAC for case, I guess, comment. I don't know what bless Nemok, which is the opposite of comment. So that language probably they wanted to close to say this is where this if ends. Don't go below. Probably if you didn't put it, it would go here. I don't know. It's like a end of yeah. You see that fee? Yeah, it's how this someone decided this language to end so that yeah after the condition it only runs down. It doesn't run the things below. That's funny. That's cute. I mean, I'm not gonna go through the problem. I'm just scrolling for some stuff. And it has thorough explanation. Here we replace the go-to with that, but we created something that is, to me, it's harder to read, or maybe it's easier to you, but it performs worse for this reason. But here it performs better. So it's like you have to be intuitive. You can't be absolute. And there are so many examples that tell that, and there is some intuition in the discussing. Like yeah, we replace that, but there is a bug here. It says can the reader spot the issue? It says this example has been used often to defend the go-to statement. Unfortunately, there are some issues. So it's a whole study of. Obviously, I'm not gonna. The part of this video is mostly the culture, but somewhere there is hidden some cultures. Here it talks about the obvious anymore that if you speed up an inner loop by some percentage, it's if you do some speed up outside, you are not gonna gain. So it's like concentrate in the places of the code that are gonna run the most time. This is where the quote comes, and we might reach the point where the quote is said to possibly conclude the video. Here it is the thing that said the convention when said by made to this software engineering calls for ignoring efficiency in the small. But look, he's saying the opposite. That sometimes there might be a gain in the small that might be significant. But he says, where does that come? It's an overreaction to the abuse they see practiced by penny-wise and pound foolish programmers who can debug or maintain the program. In established engineer disciplines, a 12% improvement, easily obtained, is never considered marginal. See, he's not saying, oh, ignore. He's saying the convention will say that. But my viewpoint, this is intuitive. This is on you. You will decide. Maybe I'm micro optimizing. Maybe I'm premature. But you should not be intimidated by that. You should be aware. You should be careful, but you should know because someone would say, I don't think this is important, or where is this 12%? Maybe it's in an outside loop. You might say it might be important later. It might not be important later. Maybe it's an easy change to make that doesn't pollute the code. Sometimes I have this. Sometimes I do an ugly optimization that doesn't gain or gains 5%. I'm like, or gains 2%, and I'm like, but I don't like this code. Maybe I'll scrap it because okay, now if that thing gained 50%, 100%, hypothetically, I would say okay, but that gives enough. Maybe I can write it a bit better. There, or maybe there is something there. Maybe if I improve another point, I don't need to do this optimization in this place. It's never an absolute where something is premature. Because some people say this thing is ignoring efficiency. Also, he might be saying not in the outside loop, but oh, we get a 12%. Ah, who cares about the 12%? 12% is enough. If you got 12% in your rendering loop, it's important enough, especially if it's an easy change. The same viewpoint should prevail in software. Of course, I wouldn't bother making such optimization on one short job. That's the other thing. Maybe you write something fast. It's your decision and your intuition. It's not a mantra of where you should do. You should leave it to the expert. You should never do it. You should not do it too early. But if you do it, if you think it's the time to do it, if you think it's not premature, if you think it's mature optimization, someone will come and say, no, that's premature, that's bad. Like it's a universal thing. I don't want to restrict myself to tools that deny. So it's all over. It's like we should not finalize that in a sense. We should have an open mind. So it's like yeah, but there is the case the grail of efficiency leads to abuse. Programmer waste enormous amounts of time thinking about of worrying about the speed of non-critical parts of the pro, and these attempts at efficiency actually have a strong negative when debugging and maintenance are considered. And here is where it comes. Here is the classic quote. We should forget about small efficiency about 97% of the time. Premature optimization is the root of all evil. Yet, we should not pass all our opportunities in the critical 3%. A good programmer will not be lured into complacency by such reasoning, but he will be wise to look carefully at the critical code, but only after that code has been identified. It's often a mistake to make a prior judgment about what parts of a program are really clear, since the universal experience of programmers who have been using measurement tools has been that their intuitive guesses fail. He wishes for compiler to provide automatic stuff. And some people say, see, now we have optimized compiler, which make much better work than you do. But the thing is, we're not talking about optimization. It's not about assembly. Optimization about being performance aware and look at the problem from various sides. If you want to spend time improving the performance, if you don't want, if it was a one-off, as he says, a one-shot job, one of like, okay, I wrote a small tool to just do something. Okay, let's. It's up to you, though. It's up to you. It shouldn't be when we make absolute rules. Then there are some experts that come. Oh, your code is prematurely optimized, and it becomes an absolute. And then people are like, I'm not gonna bother with optimize. Then, if there is the fear that I will get the dirt, the toxic, I will be the toxic programmer, the unprofessional, the bad programmer. Okay, I will stop thinking and leave it to the experts. This is what they say. So there is way more content. You don't easily know where it goes. So I said you have to know. Sometimes it's not an absolute that you shouldn't do it, and sometimes, at least in the case of Algor, go-to statements would help with optimization. That was the 70s, man. He's talking about non-optimizing compilers and optimizing compilers. Yeah, that's the error exists. Usually you see things like that in the go-to in a long list of checking for various. If something goes wrong, you want to jump at the end where you. That's fine. Yeah, and I think when the Linux kernel has such, and when people use that, it's usually for such things. And then the other is several levels of. Yeah, you have that stuff. You are in some inner loop, inner loop. You don't want to go through jumps and use booleans to jump from place one to which is harder to follow than a go to after. But you have seen the important quote. This became big. So there is code. I haven't read later. I haven't read. There is a confession. See, it's again. It's the polemic. Oh, you care about Go too. You want to defend it. You want to go back to your old dirty right ways of coding. There is a whole discussion. You cannot contain. You cannot contain this to this whole big article with the analysis of look the advantages, the disadvantages. Let's look different. You cannot contain a single dogma. You cannot contain even this. Or go-tos are considered bad. You cannot contain that whole thing. You cannot contain simplistic ideas, absolutes about programming. Destroy all creative intuition of programming. When there were so many, such a big article. And there are, between the code, sometimes there are some intuition and there are some. Different times. It might differ again how I found my students, someone said. It has quotes from other people. I found my students. Yeah, at some point I stopped the reading, but further reading, you might find some various quotes from people who are discussing programming again, but there are wisdoms, and sometimes they talk about. I found my students using this paradigm all the time. Where is it? Did I delete it? They used this paradigm all the time because they were used to the way they did in assembly. They couldn't even learn a for loop. And that was the problem at the time. But I think people naturally learned. I don't think maybe we overreacted. Here is the spaghetti thing, spaghetti code. The act of focusing our mightiest intellectual resources, mental masturbation, man. But the act of focusing that mental masturbation on the elusive goal of go to Let's Pro Guy. Yeah, this guy is pro God, but I think the act of doing that is also a bit of a mental masturbation. Okay, that subject was toxic. I'm searching for another code. Okay, I didn't go. So someone said, yeah, it's good. It's yeah. I guess it goes good. It's good to equals a necessary thing. Yeah, for example, that structured programming is not the process of writing programs and then eliminating their codes. Instead of people thinking, using their mind to think around the problem, they ended up, oh, rule number one: if I see a go-to, I must replace. And they stopped thinking about it. They think, oh, I did my job now. Because if you change your structure, you might realize, oh, I don't need the go-to if you write things a bit different. And maybe, in some rare cases, it might help. Never mention go-tos there. We were trying to solve a problem, not find with keywords and so it's not just the code, the examples, which there are some good examples. If you understand this algorithm, even if you don't understand, it's easy to read. The important thing was that there was a big discussion. There was something huge happening in the culture. It seems ridiculous from now. Somewhere, I don't know, maybe I missed it. He says a lot of readers read the thing I wrote and realized, oh, he's pro Goto, he's against Goto. While I was really doing he said, I was really doing the discussion. I was really thinking intuitively around that. I never took a part, but people will, based on their preference, their religion, will say, Knuth said that it's good to use Goto. No, he said it's good to abolish it in the future or something. He basically ended saying maybe we, in future languages we figure out ways to. Look at those references, man. Can you contain? Can you from all this thing? Can you just say? My conclusion is go to consider harmful, or my conclusion is that go to is not considered harmful. My conclusion is that premature optimization is evil, or early optimization is evil, or it's not evil, or no, he didn't say that, or but now Big West has some nice nice things to consider. If you want to think, get this in your mind. Don't do it in a absolute way. Like, it's good things to consider. He's trying to say this is mature, which is another categorization. And then someone, no, that's still premature. So people are still like, we want to define. We want to say A is bad, B is good. We just want it. It's human nature, man. And that affects culture, and I see that stuff a lot. And the the issue that happens is that at the end, a new programmer starts, and we somehow reach the point that optimization is bad or it's dangerous, so you shouldn't do it. Leave it to the experts. And again, the thing I said about wisdom, how can this be wisdom if it's taken as a mantra? Wisdom means that you ignore all that crap and you start trying stuff, you start experimenting, you do the premature optimization to learn what is mature and what is premature, to know if you have never worked with performance, how do you know when performance matters, when performance doesn't matter? Which parts of your code you could focus, or how the next time you do a new project, how to design things a bit differently, which things to decide early on and which things to decide later on. How do you know? How are these things pearl of wisdoms that everybody just throws, but they throw it in a way like they become the boogeymen of programming. So now nobody really knows. Nobody really has the intuition of how to do things, because I'm all for an orthodox program. I'm all do the things the way you want and develop the intuition. Eventually, you will improve on your past mistake. Don't. I'm done with this. The thing is that the thing is, look how the paper that this is all based. It's more esoteric and intuitive and present this social like we shouldn't be doing that. There are different cases where things are different. It's more deep than the superficial way everybody's using. And I think that article might be going into that someone said that and people thought that and people just use this thing more naively just to stick with their religion and now the whole care for performance, care for the whole thing is dirty. The whole thing. I mean, with GoTo, I don't care much because it's just one keyword, and you know, I can sometimes do without it, but I wouldn't remove it. I wouldn't abolish it. But the thing has the premature and the discussion what's mature and what's premature, because even if you do that, someone will declare most of the optimization attempts must be premature. So everything will be premature at the end. Those are some good things, and a lot of them are obvious, clear and obvious. If you are doing video games, and there might be more. Other people might have more also. I generally agree with Mick West. It's good that he brought it, and that's an old 2007 album. Man, we are flexing and mentally masturbating. I've said that a lot of times. I hope YouTube doesn't have a problem, but it's yeah, just a way of saying things. More creative, intuitive, and experimental coding, explorative, and less dogmas. And that's it, guys. That was too long. I hope to see you in another video where I'm just showing some code or previews instead of running. All I had to say, I've said it, and I don't think I will come back to this subject soon. Bye.